Hello everyone, and thank you for attending today's webinar, Raising the Bar in RWE, Addressing the Challenges of Research and Industry with AI and NLP. I'm Darcy Hodge, Digital Editor at Future Science Group, and I'll be your host for today's event. Before I introduce you to our speakers, I'd like to quickly cover a few housekeeping items. Firstly, all of the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right-hand corner. Please let us know your thoughts on today's webinar by tweeting us at the EBBase using the hashtag EBBWebinars, or simply share today's webinar with your friends and colleagues using the share widget on your screen. Some networks cause slides to advance more slowly than others, so logging off your VPN is recommended. If your slides are behind, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical questions located in the Help widget at the bottom of your screen. An on-demand version of today's webinar will be available approximately 1 hour after the webinar and can be accessed using the same audience link that was sent to you earlier. So, we are delighted to have a panel of speakers with us today. Miren Taberner from Savannah and Jennifer Quint from Breathe. Unfortunately, Angela Savan from Janssen couldn't join us today. Miren graduated from Navarra University Medical School in 2008 to finish medical oncology training in 2013. Her PhD concerned HPV and oropharyngeal cancer, and she has since published in several high-impact journals. Jennifer is a professor of respiratory epidemiology in London, leading research to better understand the relationship between cardiovascular and respiratory disease. She's also involved in institutions such as the Royal College of Physicians, Thorax, and more. While Angela couldn't join us today, if you'd like us to pass on questions to her, please email webinars@evidencebaseonline.com. We invite the audience to submit any questions you may have for our presenters throughout the webinar using the Q&A widget in the right-hand side of your screen. We will pose your questions to our speakers in a live Q&A session after the presentation, and then follow up any outstanding questions offline. Thank you for joining us today, everyone. I'll now hand over to Jennifer Quint to kickstart today's presentation.
Thanks very much, Darcy, for the introduction, and thank you also to Savannah for the invitation to speak and for all of you being here and listening today. So what I'm going to do is I'm going to start off by focusing on some of the challenges that are associated with using real-world evidence. And I'm going to focus on this from a respiratory standpoint and talk about some of the work that Breathe and some other organisations are doing to try and improve the way in which we use these data to answer clinical questions. So I'm just going to start with a little bit of a background with Breathe. So Breathe is one of 7 health data hubs that was funded through the Health Data Research UK with industrial strategy funding. And the rationale behind Breathe is to try and facilitate access to respiratory data so that we can better the health of people in the country with respiratory disease. So there are a number of different focuses with Breathe along helping NHS, academia, and also helping industry. And what we're ultimately doing is looking to maximise our expertise and help people to improve the way in which they use these sources of data that exist to answer respiratory questions. We are a partnership, as you can see, with a number of academic organisations, but also a number of public entities, charities, as well as private companies. And our overarching mission is simply to facilitate safe and responsible use of respiratory health data so that we can really benefit patients across the UK. Our collaboration is open and growing, and we've very much enjoyed working with patients as well as the public, academics, clinicians and commercial organisations to get different perspectives on the use of these data. And we are particularly keen on working very closely with the public and have quite a strong lay representation within Breathe so that the patients and the public are aware that we are using these data as responsibly as we possibly can, because ultimately they are the patient's data. So essentially what we do is we streamline access to respiratory data. We've helped to curate various different data sets so that people have the highest quality of data to access to answer specific research questions. And we've facilitated opportunities for linkage of various different data sources. So often data are siloed in specific institutions or organizations, and using a common trusted research environment, we've been able to facilitate the linkage of a number of data sets with our partnership with SAIL. And not only do we signpost in terms of access, but as I've already alluded to, we provide a lot of project management and advisory services in terms of helping people to maximize how they use these data. So I think it's fair to say that over the course of the last year, COVID has in a way really expedited how and why we use real-world data to answer questions. And I'm never sure if it's a good or a bad thing, but it seems like everybody is an expert and a respiratory epidemiologist off the back of COVID. And I think bringing this whole expertise and just signposting the importance of using these data has been one of the good things that's come out of the pandemic. We know that generally routine clinical practice generates an enormous amount of data, but actually the way in which we enter information into these systems, the way in which we report information is often inefficient. And sometimes, certainly in the UK, and this is often the case globally, the most junior person in the team is the one who actually, I would argue, has the most important job of inputting and collating those data into hospital systems. But if you think about the fact that absolutely every single encounter that we have with a patient generates data, you can see how quite quickly we rapidly accumulate information around individuals. And whether we like it or not, this is absolutely a growing field. And whether you think about that in terms of simply electronic healthcare record data or routine data for research, or if you think about it in terms of medical informatics, clinical decision support systems, using it for health economics, the field is absolutely growing, as are our methodologies and our technologies for being able to use these sorts of data to answer research questions. And I think one of the other things that's becoming more exciting is the use of telemedicine and wearable devices and being able to incorporate that real-time individual level information into healthcare systems. But these data are not without their flaws, they're not without difficulty in using them. And one of the key things is understanding the data and how and why to use certain sources of data to answer specific questions. And what I'm going to do now is just walk through a couple of respiratory examples that illustrate some of the issues that can arise with using these sources of data. So this was some work that my research group did several years ago now for Public Health England, where they said to us, we'd really like to know what's the prevalence of COPD in the UK by age and by sex. So we had just undertaken a validation study using routinely collected electronic healthcare record data to understand what codes people use and how and why they code in particular ways, to try and tease out the best way to find people with COPD within the data sets. And using our validated definition of codes, this was the graph that we came up with, which was looking at COPD prevalence across that 10-year time period. What Public Health England said to us is, well, actually, the way we would like you to have a look at this is think about people who are smokers or ex-smokers, who have prescriptions for inhalers, or who have evidence of symptoms of cough, breathlessness, sputum, and people who don't have a diagnosis of asthma, and have a look and see what the population looks like, both in terms of who's at risk of developing COPD or who we might be missing, and who has COPD, and what does that undiagnosed prevalence look like. And you can just see by comparing and contrasting these two graphs what a difference you get in estimates based purely on coding and definitions that are used in the same underlying patient population. Another really good example is one that I've got here using bronchiectasis. And this is slightly more complicated because bronchiectasis is a harder diagnosis to make than COPD, in that you need to have a CT scan to confirm the diagnosis. It is still considered a clinical syndrome, so there are symptoms that are associated with it, but it's confirmed by CT scan, by certain blood tests, sometimes bronchoscopy, and sometimes spirometry as well. And when we think about in a clinical setting, when I'm in secondary care, doing my secondary care clinics, how do I make this diagnosis of bronchiectasis? It's a stepwise process. And what you need to remember to do when you're using routine data is remember that you have to take a step back. And this sort of a definition is fine for cohorts and registries where you're proactively recruiting people into a study. But what it's not okay for is when you're using routine data to be able to take part in research. So how do we try and identify bronchiectasis in big data? Well, these are the read codes and the read terms that exist for bronchiectasis. And you think, well, there's 5 or 6 of those, that's fine, fairly straightforward. But actually, if you start to look at secondary care data, if you look at ICD-9 codes, or even add in SNOMED CT codes, as I'll show you on the next slide, then what you start to see is it becomes much more complicated. And for COPD, for example, there are over 50 codes that you could potentially use to indicate that somebody has a COPD diagnosis. And in bronchiectasis, it's not quite so many, but still that concept exists as it does across any other disease. It's not just as simple as one disease, one code. And so this is where some of that granularity and understanding is really quite important. So a couple of years ago, again, one of the things that we did was look at the incidence of bronchiectasis in the UK between a 10-year time period. This is split by men and women. And similarly, at that time, we also looked at prevalence across men and women. And so this is just split by age in these two graphs. At the same time, the British Lung Foundation was also looking at the number of people who'd been diagnosed with bronchiectasis, so also doing some prevalence estimates. And they wrote to us around the time that they were doing their prevalence estimates and noticed that what we had found and what they had found were different. And we're trying to understand where the truth lay in between all of this, because we were coming up with different effect estimates. And again, this just highlights one of the other caveats of using these sorts of data. So we used a point prevalence, whereas they looked at a period prevalence over a specific 1-year time period rather than a specific date in a point of a year. They used a different data set to us, and although they had GP practices using the same systems in both data sets, the way in which those data were curated and quality checked were different in the two databases. Some of the codes that we used to find people with bronchiectasis in the two data sets were different, and the age structures that the two studies used were a little bit different. So what we ultimately ended up with was two sets of prevalence figures that were slightly different from each other. So ours was slightly higher in each age band, but the overarching BLF prevalence was a bit higher, and that all had to do with the denominator that they used and also the fact that they had included children in their denominator. Incidence in the two studies, however, was similar, and this makes sense because it's down to mortality and loss of follow-up between the two data sets. So no study is right or wrong, but again, just highlights some of the subtle differences that you can see with using these sorts of data and the importance of understanding these sorts of data. And I can see a question there in the chat. So just to say, we have gone on and repeated these analyses with more recent data, but I'm just using these data to illustrate the points that I'm trying to make today around methodological differences. So one of the things that Breathe has tried very hard to do is to harmonize and try and encourage people to use certain code lists and algorithms. Not that that's always appropriate for every study. You really need to understand what the question is you're trying to answer and how you're going to answer it. But we can at least start by helping people and standardizing phenotypes that people can then use for using these types of data to answer specific questions. And these are all available in the public domain. as well as explanations as to which code sets and lists we would recommend using when and why, and also a very comprehensive review of the literature and code set repositories describing things that everyone else has done over time, so that for those who are really keen on coding, you can see not only what Breathe recommends, but what other studies have done in the past, which can help to explain some of the differences that studies have found in doing particular pieces of work. We've also been very excited as part of Breathe to be working with Savannah and some of their NLP and free text reading technology that they have within routine data, because adding in some of that additional non-coded information really does add value to being able to use these data to answer specific clinical questions. And in particular, we're working with them at the moment on a study on COVID-19, where we're looking at both presentation as well as longer term consequences of COVID, using some of this really detailed information from hospital records, in addition to those more structured coded data, of which I've given you some examples earlier on. So I'm going to hand over now to Miran, who's going to talk to you a little bit more about Savannah research methodology, and I'm happy to take any questions at the end.
Thank you so much, Professor Kim. So first of all, please let me thank the Evidence Base for organizing this this time for us to be sharing such an amazing thing that we have on the table, that is introducing NLP methodology to really improve research studies. And thank you so much, Professor Quinn, for being today with us. For me, it's an honor to share with you this opportunity. So going ahead, I will start with my presentation. But first of all, I would like to explain you who we are, who is Savannah. So Savannah has already created an international artificial intelligence clinical research ecosystem. We really believe that with our techniques, we really can improve clinical research. And it's not talking about that we will do it, it is talking about that we are doing it at the moment. So we have now a lot of researchers from different hospitals across the world and a lot of life science companies that are implementing our methodology to really improve or to really have a different way of seeing the data, and to really try to make more deep analysis of what it is happening to our patients now. So here are some facts. We are a company that was founded in Madrid, in Spain, but the truth is that we are now an international company. We have working with us more than 150 people. Half of them are physicians. We have a lot of doctors, biologists, in pharmacists. We have also a lot of people from the technology area. We work all together because we understand that if we make no partnership in this, we are not going to make the difference. Our people comes from 17 different countries, so we have 17 nationalities working with us, and we operate now in more than 15 countries. This is something really important because for us, it's not making small studies only in a country, but having the opportunity to include patients from all over the world. So we have deep information about what is happening in the different areas. And why did Savannah started? As it was mentioned before, I am a medical oncologist by background. When I did my PhD, the truth is that I used a lot of afternoons during 2 years to create the database that I afterwards analyzed to complete my research questions that I had. And if we think that, and if we have the opportunity to create those systems that take all the information that it is really important to understand what it is happening to the patient automatically, we have here a big opportunity. When we go through the kind of data that we can analyze in these data sets, most of the studies that has been done and talk about real-world evidence are based on structured data. And structured data is pretty important, of course, and we need to include it in our analysis. But the truth is that the most important and relevant information that we have from our patients is based on the unstructured free text. What are the clinicians writing about his or her COPD patient? What are the feelings? How is this patient becoming? So all of this information is not in the structured data, and it is so important to really understand the pathway of the patients to can predict what it is going to be happening at the end. So free text for us is a key part of the work that we do every day. So we really want to do real-world evidence, but real-world evidence, it's pretty general. That's why we create the concept deep real-world evidence. It's deep because we want to analyze and are analyzing a really high number of patients coming from different parts of the world. And this is something pretty important, as I commented before, because, for example, for create a predictive model, it's not the same to have patients participating only from Spain or patients participating from Canada, from the USA, from North Europe. So having this kind of heterogeneity, it is really a key part of making a deep understanding of what it is happening. And of course, as we have the possibility to really assess a high number of variables, this makes this an exponential opportunity for research in clinics. So we really want to go deeper and go broader and to make this approach to real-world evidence with NLP technology. And as I said before, we are now working in different parts of the world. We have in our ecosystem more than 160 hospitals. And this is really important for that, because we can really understand what is happening in different parts. We can even, at an epidemiology point of view, compare what is happening from one region to another. And this gives us the capacity of doing this deep analysis. We are not focused in a particular therapeutic area. We work in different areas, as you can see here in the slide. It is true that we have a lot of studies nowadays, for example, in oncology and hematology, but of course we do a lot of studies, as it was mentioned, in respiratory, neurology, cardiology, or for example, in endocrinology. So when we have a new area of development, we create our new models for this specific area to try to reach as much information from this kind of patients. So every single model, it is adapted for the therapeutic area that we are working in. So we can then understand that the approach of the information that we are getting, it is the most accurate one. And here you have some publications. Those are related to COVID from the big COVID study that Professor Kim mentioned before. So it's not about what is going to happen, as I said before, it is about what it is happening. We are now using this kind of techniques to really assess clinical research from another point of view. Here you have the different publications, but of course, if you want to have more, you can ask them later. And there are three big questions that we have when we talk about artificial intelligence and clinical research. Those are privacy and ownership, and the next one is validation, that we will talk a little bit more on the methodological part of the presentation. So regarding privacy, we know that privacy is one of the main and most important things for us. We want to take care about that. So we design a triple access to privacy, to assess privacy on our patients. First one, we do a de-identification in each hospital that is participating with us, and we are fully compliant with HIPAA and with GDPR. In another hand, to make it more secure, we have also developed one thing that we call natural privacy security design. So we implemented it in every single study that we do to really increase the capacity of security that we can give at that point. And at the end, we finally work in our research study with synthetic database. And one of the things that I can say is share with you to really understand that we are working in the right way is that we have now approved more than 100 IRBs by different hospitals in Spain and in other countries. So that's make us say that we are working with the most security point of view from the patient's privacy. And the other important part is that hospitals always own the data and they control the data. We only ask the data to really answer the research questions that we have. And what we want to do here is generate knowledge. We do not want the data by itself. We really want to answer the research questions and to make differences in the clinical practice. So if we go ahead and review what we have created, our own methodology, this is how a research study comes down at that point. Once we are discussing the possibility of having a new research study in any therapeutic area, what we do is that we have a viability. We really assess if the questions that the doctors, the physicians, or the sponsors want to answer are the right ones for our technology. And then we sign a study contract. Then we go through a phase when we design the study and we really understand if the data that we are getting from the hospitals is good enough to continue with the studies. And I will go more in depth a little bit later. Then we have the NLP phase models development, when we create our own and design the models for each specific research study. And of course, in parallel, we have generated external evaluation that we think it is really important to really make all the physicians and all the researchers working with us believe that the extraction of our data is good enough to continue with the study. Then we have the part when we develop our data analysis, and then we have the final study report. So I will go a little bit more in depth, phase by phase, to really make you understand how we work in Savannah. So when we have a research question, as I said, it is a really deep analysis from our team that it is made by physicians, doctors, from the people from the EH-READ and from the clinical data science to see what we want to answer, what kind of information do we need to get that answer, and what kind of methodology we need to develop. So once we have agreed the protocol, we go through a statistic analysis plan development and a predictive analysis plan development if we have predictive models in our research studies. When all of this is approved, then we start working in one thing that we call study bars. Study bars for us is a really big application when we enter all the clinical variables, all the medical terms that we really need to have extracted from the electronic health records. And we prepare a single strategy for each variable that we want to analyze. Some of them, these variables are going to be extracted directly. Some of them may be inferred at the end. So this is something that we really need to think before going through the study to really optimize the information that we are going to have. One of the most important points is data quality assessment. If the algorithms that we are developing are pretty good, but the data that we are included is not good enough, the output that we are going to have is not going to be the adequate for our patients. So we have 2 points of data quality assessment. The first one is before starting to doing all the NLP development. And this analysis wants to really understand that the data that we have from the different hospitals or clinics working with us, it is the right one. For example, do we have enough data from the departments that are considering the most important in these studies? Is this amount of data equally if we look in the every year of the study period that we have included in our research? Do we need to ask for more information that has not been integrated at that point? So trying to understand the data that we have make us be aware of some possible missing data that we can have at the end, and to ask for it, or if not, at least to have an option of how to really work with this problem. So once we have the early data quality assessment done, we need to go through the model development. So for each single project that we are doing, we create an annotation process, and this annotation is made by doctors. So we will ask the doctors to really train our system to extract the information that we want to extract. And this is something really complex in medicine, as you can imagine, because it's not only extracting the term, for example, a COPD. It is about, do the patient have a COPD at that point? Is the COPD negated, speculated? I guess the patient may have a COPD or not, or the patient do have. So those are things that are really important for us. So it's not only about getting the information from the clinical term, but it is giving context to that term. And probably this is one of the most difficult part from this model developments. So at the end, we are going to generate a really high quality structured database for an algorithm development. There are something that are important here to understand. First of all, in this final database, we will include all free text data, but also structured data. For example, if we have laboratory test results or genomic analysis, we can include, of course, this information, so we will have more granularity for the data. Of course, we are developing different models for the languages that we are using in our studies. So we optimize the models for every single language that we are using. So this is something pretty important because we need to make sure that information is getting homogeneous from the different places where we are working. And normally the terminology that we are usually using is SNOME as the most important one. So one of the better points that we have is that we have a really close collaboration between the medical experts and the NLP experts. And our models are always training between them. And this is something really important because from an engineer part of view, it is super important to develop a good algorithm, but the algorithm and the output needs to give what we need in medicine, what we really needs to find at the end. So the powerful collaboration between a medical and NLP expert is one of the most important things that we work on. Once we have our study database that will contain all the terms detected in the medical reports, we go through the part of post-processing. At that part, we do again a quality assessment of the data. This is really important also to assure that all the information that we're going to give at the end, it's good enough and it's quite high quality. So we will look through the distributions of the terms mentioned across the records and the patients, and of course the description of core NLP model outputs. And we will construct a variable table with all that information. So, for example, if we have missing data trying to determine if a patient that has diabetes, it is type 1 or type 2 because it was not written in the electronic health records, what we can do always in agreement with the researchers that are working with us and with the sponsor is to try to also infer some variables. So we can make some rules and extract more information from the direct variables that we have already had. Once we have everything prepared, we will develop our descriptive, predictive, or exploratory analysis and share all this information with the scientific committee of the research study and the sponsors to really agree on the answers that we are having. And above all, there is something that is really important. And when we started working in this area 7 years ago, what was happening is that a lot of physicians working at hospital told us, okay, but how can I believe that the database that you are extracting, it is good enough? How can I know that you are interpreting all the data that I am writing in my clinic's assessment properly? So after thinking how we could do that, we create an external evaluation methodology that now has been published, and it is shared with all the people who is doing a clinical NLP. And what we wanted to do here is to really make all the physicians and researchers believe that our structured database is good enough to continue with the study. So when a hospital works with us, as they are not going to make their own database and we are going to save a lot of time in that part, we ask 3 physicians to act as annotators. So we extract a sample size of electronic health records and ask them to please annotate by hand what do they mean in a clinical term. So we finally get a gold standard for the hospital, and we compare this gold standard to the information that the electronic health records has developed by the EH3 technology by Savannah. So we compare what we have extracted from the electronic health records with the gold standard that it is the extraction of the physicians working at that hospital. And at the end, we have a performance metric based on precision, recall, and F1 score. So we can decide that the information that we can get is good enough to continue with the process. And the truth is that most of the times that we have done it, our F1 score is over 0.9, so it's pretty good to continue with it. And then physicians are happy because they understand that the quality of the data that we are extracting is good enough to continue. So going back to deep real-world evidence, what kind of studies we can perform. So nowadays we are doing, for example, deep screening, looking for hidden patients in some pathologies that there might be patients that are under diagnosis. We are doing deep patient characterization, really understand the phenotyping of the patients of different pathologies. We are also working in deep patients journey. For example, how many times have of median a patient with lung cancer to be diagnosed? Who is the first department who has this patient on? How many time do we spend from the diagnosis to starting of the treatment? Do we follow, for example, clinical guidelines? There are things that we are understanding using deep real-world evidence. And now we are starting working also in clinical trials. We know that we have a really powerful instrument to be used in clinical trials for the control arm. So this is called synthetic control arms, and it is really important to really understand when you are comparing a new treatment or a new therapy, more about that having a specific control arm during the clinical trial to have information and what it is happening in the real world setting. This is something that gives us a lot of information. And if you can see in this slide, along all these different analyses that we can perform for deep real world evidence, predictive models are being a really interesting part of it. So prediction at the end, it is something that it is going to be introduced in the clinical setting, and using the amount of patients and the amount of variables that we can analyze from each patient, and having patients coming from different parts of the world giving their own heterogeneity will make the difference for creating these predictive models in the different studies that we can perform. So thank you at that point. Thank you very much. Here you have my email in case you have further questions for other time. And I think that now we can open the questions for the panel. Thank you so much.
Thank you so much for that presentation. I hope our audience found it of great interest and value. If you do have any questions for our speakers, then please continue to submit them using the Q&A tool to the right-hand side of your screen. I'll now hand it over to our speakers to address your questions. So anyone can feel free to jump in as soon as I ask a question. Okay. What sort of studies are you able to conduct?
So as I explained before, we have different kind of studies based on the on deep real-world evidence. And most of the studies that we have developed from the moment are descriptive analysis from different pathologies. And now we have already published and is going to be published more studies that we have performed regarding predictive analysis that I think it is something really interesting. And as I mentioned, now we are working on the development on how real-world evidence can work to help clinical trials. In that sense, I think we will have here in the following years an open window to really make these clinical trials execution more productive and more informative in that sense.
Lovely. Right then. Got a question here. How do you account for coding differences between countries?
So as we used to, as we work with SNOMED terminology, as long as SNOMED it has its own language, it is really easy to work with that. And it's not about coding. It is, for example, about how physicians also write the information in the electronic health records. That's why I explained that we adapt every model that we have to the different language and regions. For example, sometimes it could be kind of a difference how a physician from the USA can write something compared to a physician from the UK. Most important things are going to be the same, but maybe you have some linguistic issues or perhaps only administrative questions, the word information that we want to look for has been described. So SNOMED make our life easier in that sense. And of course, if we use also structured data, for example, ICD codes, it is approved worldwide, so we do not have that problem in that sense. But in the other side, it's more about thinking about the different linguistic aspect that we may have in the different languages that we are working.
Great. So I've got another question for you, Miriam, directed at Savannah. Do you have any reports or published papers reporting results or successes of your deep screening process?
Not yet. I'm super happy to share it with you as soon as we have it. We are now developing a few studies of deep screening, but I think that we will need at least one more year to have this manuscript approved and published.
No problem. So one more year, guys. Could you please advise on what sort of studies you've done in cardiology?
Yeah, hopefully we may have some information published in the following month, because we have one paper that it is now almost on proof to be approved. But in cardiology, what we have done is mainly one big study about how NLP methodology can really extract the information. So it is like a validation of our methodology issue. And now we are working on a big project that involves atrial fibrillation and anticoagulant therapy.
Lovely. So another question for you. Anyone can jump in. What type of EHRs can you gather data from?
All of them. I mean, as far as we have the information, we have expertise of navigating any kind of EHR. So there is no problem on the format, no problem on the information that we are having. The only thing that is that we need to have it at home to really extract all the clinical information for them. But we have no problem regarding the type of EHR.
Great. So with that, how do you manage to account for incomplete or low quality data within EHRs?
Yeah, this is a really, really important question. And what we do is we specifically design a part in the statistical analysis plan for the missing data. So, for example, there are missing data that if you are I am getting an example. If you want to assess if a patient has pain or not, if the pain is not in the electronic health records, we will say that the patient has no pain, and that's it. But for example, in other variables, we can make a strategy to really have the median of those variables where we do not have them, or if we can infer information from other variables that we have. As the example as I put before, if you are talking about diabetes, most of the times physicians write diabetes and don't specifically say that the patient has diabetes type 2, for example. When it is type 1, most of them will add it, but when it is type 2, not. So we can make here some inferences to work with this missing data and said that if the patient was diagnosed after he or she has 18 years old, is only with oral antidiabetics and so on, we can infer that this patient is also a diabetic type 2. So this is a really important question for us, and we have developed different methodologies to study missing data, and depend on the kind of variable that we are working with, we have a specific strategy to assess this problem.
Seems pretty comprehensive. I've got a question for Jenny here. What are the ranges of data Breathe is working with? So, for example, genomic, socioeconomic data to build a broad picture of disease.
Thanks, Darcy. So we're working across the board, actually. So environmental data, pollution data, pollen data, housing data, so looking at social circumstances, also around cohort data, so bespoke collection of data in addition to other routine data sources, definitely some genetic data within there, lab data, imaging data, or all sorts, really.
Lovely. Got another question here for Savannah. Is heterogeneity in data collection from different sources corrected within?
We work every day with heterogeneity, of course, and this is something that we are used to, and I think we can take advantages from that also. So, for example, talking about only the data, we need to really understand what kind of heterogeneity we have, if we can include all the data that we want or not, if we need to ask for more data at any point, or if some of the data we have is not enough for answering some of the objectives of the study. But on the other hand, having different patients and the heterogeneity that those patients have can improve the results that we are giving, and can, of course, give us more power to really focus on prediction models, for example.
Lovely. So Savannah covered this a little bit, but now we turn back to Jenny and Breathe. Given that patients can be sensitive about use of data, how are Breathe ensuring that patients are engaged, and what are Breathe doing in their research?
That's a really important question, actually. So we do a lot of patient and public engagement as part of our work, and actually have various different levels of involvement across different projects that we do with patients and the public. Some of it is simple as communication and people really understanding what's going on. And then there's also levels where we actually include people in helping us to frame research questions or frame how we do analyses and how we disseminate results. So depending upon the level of engagement that people want to put in, there's all sorts of opportunities available.
Great. Got another question here. What is the accuracy of using clinical natural language processing to extract the data from the EHR?
So to really answer that question, we have create our external methodology, external validation methodology, that I tried to explain before, to from some key variables of the study, make a gold standard from the annotations from each hospital participating with us, and compare it with the capacity of the EHR to extract all this information automatically. That is in one part, but of course we have an internal evaluation, and we have a specific score and a specific performance for each model that we do in our research studies. So if anyone wants to, for example, to really understand the accuracy of each model, we will always have a specific metric. And if this metric is not good enough, what we know is that we need to retrain that model because it is not good enough to extract the information. So we have like an internal evaluation for that and a specific metrics at home, and of course this external evaluation methodology. One question that you can have is why you don't evaluate all the variables that externally that you are using in a study. This is a really time-sensitive issue because we cannot ask all the doctors working in a hospital to really annotate all the information because this is big data and we are extracting a high amount of variables. So what we do in that sense is that we select with them the key variables that are defining our population, and those variables are the ones that are going to be externally validated. But as I said, we have a specific metrics internally for every model that we develop. So we have two different of validations.
Great. Oh, we've got another question just come through for Jenny here. Other than those that Jenny mentioned, what other studies are Breathe involved with?
I mean, there are too many to mention, really. There's a lot of information on what we're doing on our website and the different partners that we work with. We go across a whole host of respiratory diseases, so we're involved in a number of COPD studies, COVID studies, asthma studies, interstitial lung disease, acute respiratory infections. There's a whole host of things that Breathe is involved in.
Lovely. So let me just check if we've got any more final questions coming through. Doesn't look like it. So thank you very much, Jenny and Miran, for answering our audience questions today. Before we wrap up, have you got any last comments that you'd like to add?
I just want to thanks for the opportunity to be here with you, and thank you so much, Jenny, to be with us and to believe that Savannah has the potential to work and make the difference in real-world evidence study. And it will be great to answer any questions by email if you have some at any other point. So thank you so much for the invitation.
Okay. I would like to once again thank our wonderful presenters, Miran and Jennifer, as well as our listeners for your time and questions. If you would like to let us know your thoughts on today's webinar, please feel free to complete our feedback survey in the resource widget or tweet us at @TheEviBase. Don't forget to visit us at www.evidencebaseonline/webinars for more. Thank you for attending, and goodbye.